Thank you. So, good morning, all. I'm Iaso, and today I'm going to tell you a story about how a company scaled from a humble hackathon project to a globe-spanning abomination that no human can hope to understand. So, one of the biggest memes in the industry is this idea of scalability. A lot of the times when you hear people talk about scalability, there's an entire subset of the profession dedicated to making diagrams like this. This is the AWS reference architecture for an IoT Tamagotchi. The big problem with diagrams like this is they tell you where you ended up, but none of the story about how you got there. A story isn't only fun if you hear the end. Like, who just wants to find out about Marley and me because the dog dies at the end? So this leads to one of my least favorite interview questions ever. How did we get here? How did things get this complicated in the first place? The last time I remember doing this question in a job interview, it was on a whiteboard. It took 3 hours. We started with a single server that ran Apache, PHP, and MySQL, and recreated production from scratch. It sucked. The interviewer sat there. They were just trolling me, throwing circumstance after circumstance and incident after incident to get me to independently rederive how production got to be that way. I mean, I got it right because I got the job, but damn, it really felt like ritualistic hazing. So today, I'm going to tell you the story about this happens without breaking NDAs by making up a fake company called Shashin. Shashin is kind of like Instagram, but not. The name is based on the automatopoeia for the sound an SLR camera makes when you hit the shutter release button. But before we get into that, who is this asshole? I'm Iaso. Among other things, I am the senior cloud whisperer at Tigris Data. Tagline, Uber for globally distributed S3. I blog a lot, and I've been branching into making videos, but I'm not actually a technical writer by nature. I'm a sci-fi writer. Recent AI stuff has been fun. Today, I'm going to be taking advantage of that writing background to tell you a story about how Shashin scaled from a hackathon project to whatever the heck it turned out in the end. I've split this story into a few eras that help exemplify the stages of how things get this complicated. As I said, we'll start with the hackathon entry, we'll get into the small scale on the big cloud, and then I'm going to explain how and why things get so complicated as you span continents. And once we get to the end, I'm going to tell you how I would design something like this with tools off the shelf today. So, just so that we are absurdly clear here, and mostly because my lawyer told me I should do this story is a work of fiction. Any names, characters, businesses, places, events, and incidents in the story are either the product of my imagination or are used in a fictitious manner. Any resemblance to actual persons in living or dead or actual events in your observable reality are purely coincidental and probably there for humor. Also, when I tell this story, a lot of the irrelevant technical stuff is going to be scrambled so that you don't pay attention to it. If you recognize what anything is supposed to be, please raise your hand or laugh. Makes everyone have a good time. And just so that we're clear, when I say you in this story, I'm not referring to you personally. English is really terrible, and the you is both second and third person. So here's the character I'm referring to, just like some guy was a startup founder that stumbled his way into success. Oh, and you may have been able to tell, but this story is going to contain this thing called humor. So if you think that something's funny, please laugh. I have SRE sense of humor, so not a lot of people get it, and it makes other people feel like they should laugh. So let's reset scope for a bit. The year is 2009. The financial crisis has just stopped. You and one of your best friends have decided to go to this new thing called a hackathon. They only recently started up, and this one was powered by Z Combinator and Takaro with a $5,000 cash prize. You do the math and realize that's enough avocado toast for the both of you for the rest of the year. Your friend has been playing with this new mobile phone OS called Actroid. You both have a background in photography, and you decide you want to make something involving photography for your project. Every Actroid device is equipped with a high-power camera, and as a result of the implementation, every Actroid app has to be written in Espresso. But that doesn't mean that your backend has to be written in Espresso. Espresso has a reputation for being overly verbose and complicated to develop simple things. And you just want to hack something up quick. So arbitrarily, you decide to pick Python for your backend because you like the people at the meetup at one point. I see you out there laughing. This is how these decisions are made, and you know it. Don't even try to deny it. One of the big advantages of Python is that it has a database server asterisk in the standard library called SQLite. This makes hacking easier at a cost. So you and your friend hack it up and make it work, and it's time to show it off. You pull out your phone, you take a picture, you hit the upload button, your friend swipes down to refresh, and the crowd shows up on the projector. The room erupts into cheering, you win the hackathon, and sooner than you can imagine, you have a business being founded, and investors, they are calling you. So here's what the backend looks like at this point. The entire backend runs on one developer's laptop. This is really great from a development standpoint because it makes it really easy to hack on. But if a meteor were to hit the developer's laptop, you would be totally screwed and have to start over from scratch. There's also an app written in Espresso for Actroid. The IP address and port for the backend laptop on the conference Wi-Fi are hard-coded into the application source code, so changing it is kind of annoying. It barely works on a good day. However, this doesn't matter. You won. Relish in the piece of the victory. This will be some of the last peace you have in a while. So now you have a seed round. And with great investment money comes great responsibility to your users. So you go out and survey the options for running this thing somewhere reliably, but let's face it, it's 2009. You're going to choose the big cloud Brazil from that one bookstore named Recife. They let you pay for what you actually use, which, for 2009, this is actually innovative. This did not always exist. One of your investors suggests that you should use Postgres for your database instead of SQLite because they read the Heroku blog once and they said something that could be interpreted as Postgres being better than MySQL. So you go with Postgres. As you work and get different advice from advisors and investors, you end up with something that looks kind of like this. This is the standard type 3 three-tier architecture. This is the kind of infrastructure you end up seeing over and over, again and again, ad infinitum at every single company. Servers have 3 tiers: routing, compute, and storage. Your routing servers take requests from the outside world and send them to the application servers. The application servers convert those requests into responses, and while processing those requests, they might reach out to the storage tier. You made your backend like this. So the Actroid app is how users look at and upload photos. When the app needs to make a request, it sends a request to routing servers. One routing server will be picked at random, thanks to the wrath of DNS. And the app request will be processed and sent to an application server. The application server will, I don't know, poke Postgres or something, and then return a response. However, you're making an app that serves images. Statistically, any random request has a 90% chance of being to look at an image. So you take advantage of this by, if someone is requesting an image, it bypasses the application layer completely so that you don't have to deal with the global interpreter lock, which was still a problem in 2009 and probably will be a problem until Facebook fixes it. But the image storage server is one server. At the time the Actroid app was implemented, it didn't have the ability to write new photos to the camera roll. The camera roll didn't even exist yet. The file storage server has the only copy of a lot of your images. But Brazil is robust, right? It wouldn't just go down randomly, would it? Would it? Wrong! It's 4 a.m. and you wake up because everything is down. Raise your hand if this is relatable. Also, for your Zoomers in the room, this is called a pagare, and the name comes from the French word for screaming infant that prevents you from sleeping. So this time in the pager zone, everything is down, and when people go to the website, they see this image. Your app is breaking amazingly, and this is the thing that's on all the feeds. Users are complaining on a service originally made for commenting on podcasts over SMS. I think they call it Why Now? So a heroic effort ensues. The application is brought back online. However, when you're post-morteming, you realize that some images were corrupted. Luckily, it's only the last 2 images that were uploaded before it all fell over, but this corruption, it scares you. The image server literally died under the weight of all the uploads at the last minute, and you lost user data. In your post-mortem analysis, you realize that all of production resting on a single server is probably a bad idea. And for some reason, if your backend goes down, the file storage server is down, and this is not good for uptime. An investor suggests that you use this thing called Brazil Simple Object Storage for uploads instead of a server with a bunch of files on it like you were trained in college. SOS allows you to put bytes into the cloud with a name and then use the name to get the bytes back. And unlike everything else with simple in the name, this is actually simple. So SOS saved the day. With this, you're more easily able to trust that one server going down won't destroy your user data, asterisk. However, at the time, Brazil is the only thing with something like SOS. If you ever wanted to move off of Brazil for some reason, SOS would keep you locked there with terabytes of data, charged per gigabyte of egress. So at this time, the team is about 16 people, including you, the CEO, and the rest of the team. Oh yeah, you're the technical co-founder. This is still small enough that everyone can have a rough idea of what the entire thing is doing at once, but something big is about to change this. 2 words, and one of them is a letter. The big pile of money has slowly started to run out. In order to keep the company online, you need more money. You talk with investors, you get lucky, you pass the great filter of startups with a Series A round. And just after you announce everything, the investment news goes live, you get a flood of users, the pager starts going off multiple times. People can't upload new photos, but they can sometimes view existing ones. It's worse than you think. The database server is falling over, and each additional user you get makes the problem worse. You're viral. You eventually get it working somehow. We're not sure how, but in the postmortem analysis, someone realizes that the app makes a lot of the same requests to the database over and over and over. If you could somehow save those queries to some place for a short time, it would make fewer requests. So you ask an investor for advice, and you hear about this program called Valky. It's a bit like this Redis thing you might be used to. You can use it to put database results there for a bit instead of having to run the same queries over and over again. This buys you time to figure out what you need to do with your database server. So Valky is now a permanent part of your tech stack. It works great, and you're really happy with it. And then the pager goes off at 4 a.m. again. It's always 4 a.m. It's never any time else. You shake off the grogginess and realize the horror of what has happened. The Valky server crashed while it was writing to disk. The cache is gone. Clients were constantly trying to remake requests in order to hide downtime because of some clever code a junior developer added. Because the cache was empty, everything had to hit the database, and it was trying over and over again when it timed out. Congratulations, achievement unlocked, thundering herd. Your database server was assaulted into submission. Thanks to all the spare capacity you had with Valky, you were able to set up a read replica to the database. Thinking quickly, you decide, hey, what would happen if I made the request go randomly between the primary and the replica database? Somehow it worked. The app is back up. This event soured the taste of Valky in your mouth. Thundering herd problems, let's be real, they suck in general. They're really easy to make on accident, and they're really hard to deal with because you have to turn everything off or something, and that's difficult because DNS hates you. But now you depend on Postgres replication. And at this point, your backend is getting more complicated. You had some experiments, but now they're permanently welded to production. And more critically, you're about to hit the theoretical I/O limits of your Postgres setup. Your database replica is on its last legs, and you're going to need to spin up more replicas and fast because you've gone viral again due to some influencer doing something. I don't know. Someone tells you about a configuration management tool called Aerodactyl that can help. You create a database server by hand, fossilize that with Aerodactyl, and then create 7 more. Everything works the first time. You're amazed too. You adopt Aerodactyl across the fleet. As this happens, you're about to hit another great filter in terms of startups: the transition from a big small team to a small big team. As a result, people are starting to specialize and go out to different parts of the app. And this is usually the point where you see teams forming around these aspects with their own volitions, their own goals, their own product visions. Then you run into problems with your version control system called Ruffian. When multiple people are modifying the same files in Ruffian in different yoink requests, you get merge conflicts. This was academically interesting the first time, but it quickly became a headache, and then a migraine, and then a cluster headache. Forward progress was impossible, but you can't just switch away from Ruffian. It's got its tentacles everywhere. And this kind of conflicts is how you end up with microservices. Your backend gets carved up into different parts managed by different teams. So In the ideal spherical cow reading of microservices, every microservice has a well-defined API that it uses to communicate with other services in order to separate concerns between team boundaries so that people don't have to fight over merge requests or not. Raise your hand if you've ever seen this happen in the real world. Maybe a couple? Yeah, it never does. Raise your hand if you've seen the opposite of this happen in the real world. Yeah, many more. Okay, perfect. The image uploading team was patient zero for microservices. They were having reliability issues when you were uploading stuff through the main monolith. This is an app around image uploading. So if images can't be uploaded, you're going to have a bad time. The monolith was having a spate of segmentation faults, even though that should be impossible with Python, but life finds a way. At a certain point, push came to shove, and somebody just made a separate image uploading service as a test. It worked. Microservices are now in production. As other teams started to run into ruffian merge conflict issues, they ended up writing their own microservices too. Okay, so I realize here that I'm selling microservices as some kind of panacea or cure-all, but really they're a trade-off. Microservices can make things more robust at the cost of things being able to be half down and half up. The image uploader can be down, but everything else can still work, or the image uploading can work and everything else can be down. You're not easily able to tell when things are actually broken, and your uptime monitoring gets fractally complicated. And this is how the diagram of backends gets really complicated. So the main monolith ends up looking like photos or comments or something, and everything else is carved out into other parts. Like some people decided to name things after Star Trek for some reason, so you have Uhura sending out push notifications, or I don't remember how to pronounce that word in Latin, monitoring everything or whatnot. And everything was carved out, and everything was built by different teams, and everything kind of was interoperable, but there were like 5 programming languages based on what person decided to write things in. So it was a bit chaotic, but it did work, asterisk. As you grow over the years, you start to run into a fundamental problem that you can't really change without a lot of effort that you've been trying to put off, because it just sucks trying to fix it. The speed of light. Computers are fast, but it will take a light particle 100 milliseconds to get from Northern Virginia to Europe. You need to expand into multiple regions. This is the real great filter for these kinds of things. It's not investment. It's not teams. It's making a true distributed system. Because making distributed systems like this come with a lot of problems that you get nowhere else except Google, and you're not Google yet. However, due to the design of the rest of your stack and the way users actually use the service, you get really lucky. The majority of things that are slow involve reading data. Statistically, 90% of your requests are reading data. So you can half-ass it by having each region really just be a bunch of caches, and maybe a read replica or 5. Your application will just poke the main database over a VPN or VPC or whatever the hell acronym, whatever something needs to change. This makes it relatively trivial, asterisk. However, once you go past this point, you have a huge problem where nobody's able to understand what is going on anymore. You don't just have a backend at this point. You have an ecosystem of tools that interact with each other in ways that nobody really understands. This is probably the point where having something like Kubernetes might be useful. But anything below this scale, it's probably not the best use of your time. But who am I? I have a Kubernetes cluster in my home lab. However, you have a bigger problem. You've done more investment rounds, but the big mountain of cash is starting to run out faster than it's getting replenished with investment. It's looking like your only exits are to go public and sell. However, either way means that you get to retire. After entertaining a couple offers in the private market, you decide to sell out to, let's call it Hieroglyph. You get to retire at 45. You win. So let's go back to reality a bit. It's 2024, the cloud is a thing, and there's actual real competitors to the big cloud. How would you make something like Shashin in the real world in a way that's both understandable, sustainable, and gets you some of the advantages of the globe-spanning monstrosity without any of the disadvantages of not being able to understand it? Realistically, I'd probably use a cord of these tools to build up the infrastructure I need. Note my bias. These companies succeeding means I'm more likely to be able to retire myself, but realistically, every deployment needs compute, network, and storage, and these two things will give you that in spades. So the overall backend diagram would look kind of like this. I realize now that I made this too small. Oops, I didn't edit my slides last night. In general, though, the main monolith handles everything. It has a bunch of instances that scale up and down based on the needs, but the only major exception is image uploading, because let's face it, it's an image uploading thing, and the image uploading thing is the thing you want to be the fastest it can possibly be. Image format conversion is also one of the worst cases in computer science because it's both CPU and memory intensive, and you definitely want to be able to spin that up and down and not have that all running at full blast all the time because you just waste money. Investment isn't that infinite. So I put all the images in Tigris, TLDR, S3 plus a CDN. Having the uploader service work in every region means that all the images would be by the users by default. So why should you have to upload an image to Northern Virginia from Minneapolis for people in Minneapolis to view it? Doesn't make any sense. If you have any questions about this, please ask me in the hallway track. More than happy to answer. I have stickers. In conclusion, there's a couple things I want you to take away from this talk. Every diagram has a story. The complexity that you see in various backends happens for a reason, and some of those reasons are lost to time, conveniently. Unless you're at the stage of a globe-spanning abomination, you probably don't need Kubernetes, but the ecosystem of Kubernetes basically swallowed up all of the competitors and got rid of them, so... And finally, storage is hard. There was more about this, but I had to cut it out for time. And before I finish this up, I want to thank everyone on this list for helping me make this talk shine. Your efforts have been noticed, and you are loved. And thank you for listening. I've been Iaso, and I'm going to be walking around the hallway track in case you have any questions or, like I said, want stickers. If I missed your questions, please email shashin@zserve.us. If you want stickers, again, I have them. Have a good day, everyone, and stay safe.